Hello everyone, and welcome to this webinar from Blueprint. For those of you who are unaware, Blueprint is a strategic consultancy focused on 3D printing and additive manufacturing technologies. With 15 years of experience providing strategic, operations, and applications consulting, we are hyper-focused on helping our clients understand additive, identify its benefits, and make these benefits a reality. Additionally, we provide insights, tools, and methodologies freely and openly to the wider business community. To learn more about who we are and what we do, go to our website, additiveblueprint.com. Let's now focus on the subject of this webinar, Beyond Products, How 3D Printing Can Drive True Business Innovation. Before I get started, I'd like to introduce who from the Blueprint team you'll be hearing from. My name is Kunal Mehta, and I am the head of Blueprint. I have 13 years' experience in providing strategic consulting for Fortune 500 companies looking to adopt and integrate emerging technologies into their business. From cloud computing to customer experience, AI, and now additive manufacturing, I've had the joy of working on and leading hundreds of projects from concept to delivery. What drives me is helping our clients take advantage of new technologies that can propel their business forward. And later in this webinar, you'll be hearing from my colleague Oliver Smith, our senior innovation consultant and resident creative thinker. Starting with human-centered design, he has built countless 3D printing innovation frameworks for our clients and for public use to allow anyone to meaningfully innovate their products, services, operations, supply chains, and business models. In short, he helps our clients change how they think, operate, and do business using additive. If you want to reach out to either of us, then please do so. Drop us an email to hello@additiveblueprint.com, and we will be sure to start the conversation. And now on to our webinar, and let's talk about the title, Beyond Products, How 3D Printing Can Drive True Business Innovation. What do we mean by this, specifically the phrase beyond products? Well, back in the heyday of 3D printing media coverage, around 2010, at the summit of the Gartner hype cycle curve, we had great expectations of this technology. You would read in The Economist that 3D printing was poised to trigger the third industrial revolution. Wired and Time magazine claimed the rise of consumer 3D printing would change the world. Perhaps the one that I'm reminded of time and again is The Economist's front page cover, Print Me a Stradivarius. A headline so provocative, it spurred a Fortune 500 to engage with us on a year-long project to measure the effect of 3D printing on global shipping and trade revenues. You'll notice that during this time, we were not talking about product innovation. We were talking about wholesale disruption to decades-long industrial paradigms around mass manufacturing and global supply chain configurations, to the empowerment of individual consumers through the democratization of production technologies. 3D printing was going to do more than innovate products. It was going to upend our world and fundamentally change what and how we make, move, and use things. Almost a decade on, have we lived up to those lofty expectations? Do we live in an additive world? For my portion of this webinar, I want to explore that question. And to help me answer that question, I need something that all good consultants use, a framework, a set of metrics we can use to assess the data and make some sort of assertion. And I want to use the most basic metric of them all, arguably the only one that matters in the end, money. In the 10 years since the Economist article was released, are we seeing evidence that businesses and organizations are applying 3D printing innovation to grow their top line, strengthen the bottom line, and capture lost revenue from the long tail? Let's first look at the measure that shareholders, analysts, and traders like to start with when measuring success, the top line. Is 3D printing helping companies make more money? First, let's acknowledge some facts regarding the economics of 3D printing. In most cases, the piece-part economics of using 3D printing over alternative, more conventional forms of manufacturing do not usually work. 3D printing as a means of production is expensive, which is why claims from publications and commentators saying 3D printing will displace mass manufacturing are often idealistic than technological and economic reality. But despite this barrier, a wide variety of industries are utilizing 3D printing to drive revenue growth. The key to these success stories is that they are not replacing like for like, substituting their existing production methods with additive manufacturing. They are leveraging a unique capability of 3D printing to either rapidly advance the performance or quality of their products to dominate a market, or alternatively, they are following a red ocean, blue ocean approach and creating entirely new markets that can be assessed and serviced by using 3D printing as a manufacturing methodology. From medical implants to bicycles, from home furnishings to apparel, the ability to create bespoke products or to create products that outperform their conventionally manufactured counterparts is empowering forward-thinking companies to drive up that top line in a direction that was not possible with traditional manufacturing technologies. Let's look at a couple examples. Medical prosthetics and gaming merchandise, two distinctly different industries, but each demonstrating how 3D printing can forge and secure new revenue streams with some innovative thinking. Let's look at Unique, a medical device company based out of San Francisco that has capitalized on 3D printing's ability to create one-off unique products to provide mass-customized orthopedics and prosthetics. Why is 3D printing a solution for them? Their core belief is that in today's age, prosthetics are becoming less a reflection of tragedy and instead an expression of personality. And to service this shift of consumer attitudes and expectations in the market for prosthetics, Unique uses 3D printing to allow their customers to customize their prosthetic coverings through a smartphone app that feels more like a personal shopper experience than medical device catalog. From color, size, patterning, and more, then they have this product 3D printed. So even though 3D printing might be a high-cost method of production, its flexibility to produce one-offs compared to the processes makes it an ideal solution to enable this offering. As co-founder of Unique, Ethor Bender describes, there is a level of customization that needs to be applied to most of our devices, and 3D printing is the only technology that can affordably achieve customization and scalability. And Unique are not the only ones who are jumping in to provide this emerging market demand. Companies like Mercurius, Prosthetics, and ProssFit are using 3D printing to provide 3D printed customization to elevate and distinguish their products and snatch revenue in a market dominated by the likes of Stryker, Zimmer, Biomet, and Smith & Nephew. So what about gaming merchandise? The digital games industry is big and expanding fast, with revenues of $131 billion in 2018. Primarily driven by digital content, especially smartphone content, there's still a huge opportunity for games developers and content owners to levy the value there beyond digital games. Case in point, Rovio, the company behind Angry Birds, made 40% of its $200 million through licensing, which includes merchandise. But the more high-end games such as Halo, Fallout, Destiny, which can cost upwards of $60 and demand countless hours of gameplay from players, are stuck in a difficult position. The developer of these games recognize the value of their IP is much higher than free smartphone games, and their gaming communities are much more loyal and willing to invest. But equally, this community wants merchandise that is a reflection of the character's individuality, the achievements, and the worlds they've built in these immersive games. So developers have rich and valuable data, but lack pathways to sufficiently monetize it. This is where Sandboxer, a 3D printing bureau and software company, since acquired by White Clouds, stepped in to provide a solution, a 3D printed merchandise platform for video game companies. In short, Sandboxer have created an in-browser customizer that allows gamers to find the model of their character, customize it with postures, weapons, and other decorations, and then pay to have a customized character 3D printed as a figurine. The game's developer licensed the use of the digital characters to Sandboxer, who manages the customization and 3D printing of this content. And the game developers take a percentage of revenue from the sales of their characters, creating a new revenue stream for high-value customized content that was previously locked up in games and now made accessible thanks to the ability to 3D printing to produce low-volume customized products. So that was two examples how 3D printing is unlocking new revenue streams and providing others with new mechanisms to carve a niche in highly competitive markets. Now let's look at the bottom line. Is 3D printing enabling companies to lean their operations and to cut costs across the enterprise? Whether it's cutting delivery lead times, ensuring uptime through more effective preventative maintenance, cutting management and operational costs by consolidating supplier networks, or accelerating new product development times, 3D printing is indeed allowing organizations from aerospace to industrial equipment manufacturers cut costs. But more often than not, these savings are only achieved when a broader enterprise-wide perspective is adopted. Why? Because where in one part of the business, say procurement, a 3D printed part might be deemed too expensive, in another, say inventory, the choice of buying a smaller volume of those parts, possibly even a single unit, would be preferable to buying a minimum order of several hundred. In this scenario, the 3D printed parts are more expensive per individual unit, but the savings are made by eliminating a more costly minimum buy order. The key to making 3D printing cut costs in a business is to appraise the entire life cycle of a part. It takes an enterprise-wide approach, which often demands fundamentally business change. Let's look at a couple examples. Firstly, Caterpillar, a Fortune 100 heavy equipment manufacturer based in North America and exporting around the globe. How are they utilizing additive to cut costs? At its Philadelphia plant, Caterpillar decided to do something a bit left field. They installed a cell of 3D printers and opened up access to anyone in the plant to use them, encouraging everyone from designers, engineers, and line operators to innovate with this new tool. Taking this bottom-up approach to innovation paid off. By allowing the people who were most familiar with all the discrete processes, applications, operations, and the jerry-rigging and workarounds that are commonplace in manufacturing environments, 3D printing could be used to make many incremental improvements across the plant. Now, to have identified those many small applications for 3D printing from a top-down approach might have worked, but the cost of such a program may have been more than the savings identified. Taking this bottom-up approach was quicker, broader in scope, and identified opportunities that were below the radar. That would have been impossible to identify if they had not empowered their staff with a mindset and tools to solve the problems additively. And the proof of the success is in the numbers. From using 3D printing to produce all manners of components and tools across the line, from hose clamps to chain links to pre-production models and jigs, the Philadelphia plant made hundreds of thousands of dollars in savings. With just a single 3D printed track link saving $160,000 and a masking mold for spraying ABS plastic saving about $27,000. In short, Caterpillar decided the best approach to applying this technology to find these hidden savings across their organization was to democratize and allow the company to organically innovate, just as they would with any other tool. And now let's head 100 kilometers straight up with Relatively Space, an American aerospace startup founded in 2015 with the goal of dropping the price of launching into orbit by an order of magnitude and provide launch systems that allow for true commercialization of space. With their founders Tim Ellis and Jordan Noon both having prestigious backgrounds in the field in working at SpaceX to sitting at the National Space Council Advisory Board, they realized that to achieve the goal of making access to space affordable, wholesale changes would be needed to the current paradigm in both how rockets are designed, manufactured, sourced, and launched. They needed to shift from the dependence on high-cost external suppliers with long lead times, heinously complex rocket designs, and huge costs incurred throughout the supply chain when building and launching a rocket. Complex designs, complicated supply chains, and prolonged lead times. With these issues in mind, Tim Ellis decided the only one technology that could provide the solution at its core relatively is creating an entirely new, fundamentally better process to build and fly rockets. He said, "We view 3D printing as the future for all rocket production and aerospace manufacturing, because how it reduces the labor and part count of these very complex parts." Their 3D printed rocket engine, named the Aeon 1, is both a far simpler and more reliable design than conventional engines, but also far quicker to manufacture, with a production time around 15 days compared to the 180 days for the production, sourcing, assembly of a conventional rocket engine. This production cost and lead time reduction, coupled with the capability of 3D printing to allow for modification of the rocket design based on customer specifications, Relatively Space can live up to the promise of providing commercial space launch service an order of magnitude cheaper than what was currently available. And the final metric, capturing long-tail value. You might ask, what is the long tail? The long tail term is not that old, coined in 2004 by Chris Anderson, editor-in-chief at Wired magazine, and describes the idea that many small transactions, low-volume sales, and products in low demand can, when considered as a whole, rival the revenue generated of a few market-leading products. I prefer to view this theory slightly differently, in that most products actually have a long tail, some longer than others. A car, for example, has a long tail of years, even decades, whereas a smartphone might have one for a couple years before it's scrapped. In either instance, the long tail represents the length of time available to continue making money from the products after the initial sale. With a car, it can be serviced and maintained. With smartphones, it can be phone cases, devices, attachments, camera lenses. The question is, who is the one making the money from the long tail? Is it third parties or is it the OEM? This is where 3D printing has potential to disrupt the dynamic in the long tails of many different industries and in effect add fuel to the arms race between OEMs and third-party providers. As a low-volume production strategy, 3D printing can allow both OEMs to regain lost value in their long tail by providing more post-sale products, upgrades, and services, whilst at the same time allowing third parties to set up shop and begin offering aftermarket products and services without ever having to invest in capital equipment themselves. So what does this look like in practice? Let's start with an OEM, namely Porsche. Porsche has a long and prestigious line of vintage vehicles still on the road today. And as I'm sure you'll all agree, the owners of these vintage iconic vehicles will stop at nothing in the hunt of authentic replacement and spare parts for their cars. They are keenly aware of both the loyalty of their customer base, but also the value of maintaining such iconic vehicles. So Porsche have invested significantly in maintaining parts catalogs, inventories, and provider and supplier networks to ensure they can provide genuine certified parts to their customers. Striving to continue this level of service, Porsche is now engaging in a 3D printing initiative to digitize a growing portion of the classic car catalog. And the reasoning is simple. Rather than have to reproduce minimum quantity of classic car parts using the original tools, or pay for a new tool to be reproduced, having a digital catalog of parts means individual components can be 3D printed on demand, reducing carrying costs as well as ensuring that these parts will always be available in the future. But in the context of the long tail, what Porsche is doing is putting in place a strategy to lock out third parties from stealing long tail value. Now, what about something less sexy as vintage sports cars, but instead copper induction coils? Induction heating is often used in the metalworking industry to induction harden metal parts that might be subject to significant wear and mechanical loads. To create the copper inductor coils can take several weeks or months due to the complex designs required by the end user and the bending and machining processes required to create them. Proteek, a design and manufacturing service provider, saw an opportunity to use 3D printing to cut this lead time down to days, but to also allow industrial customers design inductor geometries that were far from efficient and impossible to fabricate using current methods. Choosing from 6 basic inductor shapes through an online configurator, a user can modify simple customization interface, the design of their coil from a number of turns, coil diameters, channel diameters, and connector positions. And all these changes can be seen on a screen in real time with dynamic pricing updates, allowing you to see exactly how much your customized inductor costs every time you change the design. So not only are Proteek providing a superior industrial tool that is both cheaper and quicker in the delivery by using 3D printing over conventional manufacturing methods, they are capturing revenue from a long tail of induction hardening equipment manufacturers such as GH Electrotermina, Thermo Machine, and EMAG, who provide induction systems, but have abandoned their long tail and allowed the likes of Proteek to service customers of those OEMs who are demanding higher performance, cheaper, and customized tooling solutions. So based on the 6 examples we've seen and the broader implications of 3D printing that I've described, have we met the expectations laid down back in the late 2000s? Sure, each of the examples we've just demonstrated how adopting an additive mindset allows you to do more than innovate products. It can be used to create new business models, reconfigure internal processes, and open up new markets. But are these indicators of an additive revolution? We need a quantitative benchmark to at least give us some quantifiable comparison to measure the rate of additive adoption. 2018 figures show that additive manufacturing market reached $7 billion in revenue. That is the value of all the equipment, materials, and associated services. Let's now compare that to some of the emerging technologies that are equally new on the scene and have received significant media attention. 2018 figures for the global commercial aerial drone industry stand at $6 billion, and the global smartwatch market is valued at $9 billion. This comparison, I think, helps us appreciate the actual degree of adoption and impact we are seeing with additive manufacturing. Behind the standout success stories we often see in the media, including the examples I've shown you, the total value of the additive manufacturing currently stands at 0.02% of the global manufacturing value, a stark rebuke of the predictions made by the likes of The Times and The Economist. So this begs the question, if 3D printing can significantly drive top-line growth and bottom-line savings, as I've described and demonstrated to you, then why has there been no revolution? Quite often, conversations about technology emergence and the impact it will have on any given industry suffer from a significant blind spot. When talking about the technology, we often leave out the human component. At Blueprint, we believe that this has been the blind spot in the conversation about additive manufacturing. We as an industry have failed to consider the human aspect and the very real psychological barriers to new technology adoption that have to be identified, considered, and overcome when talking about, as The Economist described it, a manufacturing technology that would change the world. Bill Taylor, co-founder and editor of Fast Company magazine and a prolific author on the subject of corporate innovation, said it best. You're not buying a piece of technology or hardware. You're buying into a new mindset and a way of doing things. He too realized that the issue wasn't technological capability, price, or quality. It was a human ability to think beyond how we have always done things. So if there's to be an additive revolution, then like every other revolution throughout history, it will not be led by machines, but by people. So we've determined that we are facing a human barrier, but not a technological limitation. Now let's explore this in a little bit more depth. What are the human issues, concerns, and limitations that are preventing more wide-scale additive adoption across industries? In a survey of 200 business CEOs representing a spread of industrial manufacturing across North America, 2 questions were asked. The first was what they believed to be the biggest challenge to introducing 3D printing into their manufacturing operations. The available answers included the typical assumptions made of additive manufacturing: cost, integration, supply chain disruption, etc. But they also included human-focused barriers such as management focus and business knowledge. So how did these 200 CEOs respond? The second and third highest answers by far were human barriers, management focus, and business knowledge. And the biggest barrier is a technical knowledge issue, still a very human problem. Most noticeable of all is that the most cited barrier to additive adoption, cost, is the second from the bottom in terms of the biggest challenges for companies when evaluating 3D printing. The second question asked was where these CEOs and businesses were in their additive manufacturing journey. Were they just starting out, or had they made 3D printing a core component in their operations and success of their businesses? Unsurprisingly, the majority, 84%, had not moved beyond prototyping, which is the historical and most rigorously proven application space for 3D printing. So with our proposition that human concerns and a lack of knowledge and skills is what's holding back additive adoption, what can we make of these numbers? We can make a simple yet stark statement about the core dynamic at the heart of our industry, and one that we believe has yet to be fully addressed, but is the final major roadblock to seeing much greater levels of additive adoption across industry. And it is these 2 numbers. 84% of businesses are interested to move beyond prototyping and leverage the benefits of additive throughout their business, yet 85% are unable to move due to the lack of human skills, business acumen, and technical knowledge. So how do we go about changing these numbers? What mindset can we adopt that will enable designers, engineers, and business leaders to not only understand the many nuanced capabilities of 3D printing as a production methodology, but also learn and apply those capabilities to innovate their own businesses and internalize an additive mindset, which provides the confidence to move, just like Porsche, FedEx, Adidas, GE, Stryker, and other forward-thinking companies, from that 84% to the 16%. This is where I now want to bring in Oliver Smith into the conversation to present to you just such a mindset, our 6 business drivers of 3D printing. Built and refined over the course of a decade through thousands of hours of additive consulting engagements, this framework lays the foundation of our approach to 3D printing, one which we educate our clients in so that they better navigate 3D printing. We look forward over the course of this webinar series to teach you this mindset so you too can become an additive innovator. Oliver, the mic is yours.
Thanks, Kunal. So, for my portion of this webinar, and throughout this webinar series, it will be my job to demonstrate to you all a new mindset that, as Kunal described it, allows us all, from individual designers to organisational leaders, understand and evaluate how 3D printing can drive business value. So, the new mindset, this framework for thinking about additive, is surprisingly simple, and it is our 6 drivers of business value. As Kunal mentioned, the 6 drivers framework was built from the insights gathered from over 100,000 hours of 3D printing consulting across virtually every industry, from energy generation to cosmetics. Where did it come from? During the early days of our consultancy, we began to notice trends, underlying patterns in our recommendations for how 3D printing could help grow a business. And we knew there were some fundamental principles at play, so we decided to analyse all of our previous consulting work, as well as survey industry and review all the available literature to see if our instinct was right. Was there a set of rules at play? And from that research, we codified a set of fundamental principles from which all our consulting recommendations, industry expectations, and public research could sit upon. We called it the 6 drivers of business value. The 6 drivers each describe a fundamental facet of 3D printing, how it can uniquely change how a business does business, from how it designs products to how it can redesign its business model. But most importantly, as technologists, we have promoted a technology-centric mindset to communicating and educating the market on why 3D printing is so special. The 6 Drivers framework promotes a very different approach, one based on business value and communicating the human and organizational implications of the technology. In short, this approach ensures that we as designers, managers, leaders, as people, understand the implications and benefits of what 3D printing can offer us, what these changes can look like in terms of your organizational processes, your business structure, or your strategy, and empower us all as independent contributors to managers to business leaders to start the conversation about 3D printing and approach this technology with a business mindset, not an obsession with layer heights, deposition speeds, or machine costs. So, for the remaining half of this webinar, I want to give you an overview of the entire framework, stopping each one of the 6 drivers along the way to give a brief explanation and share with you some case studies that show you what these drivers look like in action. So let's jump straight in with our first driver, freedom of design. Certainly the most familiar aspect of 3D printing. As a layer-wise additive process, 3D printing allows us to create highly complex shapes and geometries that would be exceedingly difficult, if not entirely impossible, to produce using conventional manufacturing methods. This capability of 3D printing is what we call freedom of design, and it's a direct reference, if not a somewhat subtle one, to the well-understood process of design for manufacture. So design for manufacture is the rule that a product must not only be designed to perform its intended function, but be designed so that it can be manufactured and assembled using a specific set of tools or processes. A good example is an injection molded part. It can't have any undercuts in the design, or it won't be able to release itself from the injection mold, making it designed for function possibly, but certainly not designed for manufacture. What this can lead to is compromise. The design changes required to ensure a product can be manufactured, say using injection molding, CNC machining, or sheet metal forming, can compromise the designer's ability to create a 100% performance optimized product. After all, there's no point in designing a 100% optimized part if that design can never be made physical because it can't be manufactured. And here is where freedom of design shines through. 3D printing does not need to abide by many of the design for manufacturing restrictions that govern conventional manufacturing processes. This allows designers and engineers to freely design products that are far more optimized for their intended function, and know that these highly optimized designs can indeed be realized in the real world thanks to 3D printing as a production process. A great example of how freedom of design can allow the creation of functionally optimized parts is a conformal injection mold tool from Texa, a toolmaker based in Italy. Injection and die-cast mold tools are often designed with cooling channels running within the body of the mold. These channels help to cool down the injection or die-cast part more evenly. They allow for a more controlled temperature as well as more rapid cooling. These channels are created by drilling multiple times into the metal mold tool, creating a network of intersecting straight channels, or maybe just individual boreholes. Although effective, this approach is not optimal. Texa saw an opportunity for 3D printing to allow for the design and production of a far more optimized tool by using freedom of design, specifically the ability to 3D print non-linear holes, channels and features within a part that conform to the shape of your tool design. And so a mold tool insert from Texa, complete with those non-linear conformal cooling channels, only achievable by using 3D printing, can boast a cycle time reduction of up to 40%. That's impressive, essentially meaning your tool is now twice as fast. And this is just one example of how freedom of design can drive performance. Whether it's aerospace brackets or hip replacements, having the ability to design and manufacture beyond the limitations of conventional manufacturing methods is allowing organizations to make huge strides in the functionality, efficiency, and performance of the products that they design and make. So let's stay on the subject of design with our second driver, but begin to start thinking outside the box with embedded functionality. What do we mean by embedded functionality first off? In short, it is the principle that by using a layer-wise process that allows us to position multiple materials in precise locations within a print, or integrate components within a part as it's being constructed, we can create parts that have pre-programmed behaviors, embedded sensing, passive actuation, and much more. In short, we can begin to create smart products. Phrases you may have heard when reading about 3D printing, such as electronics, 4D printing from Skylar Tibbetts at MIT, soft robotics, multi-material printing, are often referencing some form of embedded functionality. 4D printing, for example, is the design and printing of parts that comprise of multiple materials that possess different properties to different forms of stimuli, whether that's moisture, heat, light, or something else. This multi-material matrix is designed in such a way that under specific conditions, the materials in that part will start to react and deform or change their properties in a very precise, pre-engineered way, and they can contort themselves into very particular shapes. Imagine the net shape of a cube sat on the table in front of you. When we expose that to a particular wavelength of light, or maybe a range of temperature, it will then the materials within that net will start to react, and the flat net will begin in front of your eyes to begin to fold into a closed cube. Now that's one of the more bleeding edge examples of embedded functionality, I will admit. But there are other examples that are far closer to commercialization. One such example that demonstrates the commercial viability of this idea is to combine 3D printing and pick-and-place electronics to create products that contain complex electronic systems. Voxelate, an interdisciplinary spin-out of Harvard University, built a multi-material 3D printer that could print in thermoplastics through a material extrusion process, as well as highly conductive metallic inks using a slightly different extrusion method. What this printer allowed you to do was to print the body of a product, say a simple quadcopter, but also 3D print the conductive tracks for the electronic components of the drone, which themselves, thanks to the open nature of the printer, could very easily be inserted in situ as the drone was being printed, culminating in a drone that had the capability to, in essence, fly itself out of the printer when it was done. So embedded functionality can range from creating smart materials that change their properties or shape when confronted with heat or light, or it can mean using simple 3D printing architectures to enable the creation of fully encapsulated electronic systems within a product. So whether it's athletic shoe insoles that actively change their porosity in the presence of sweat to allow the shoe to breathe, or telecoms companies laying down submarine communication lines studded with amplifier units containing hermetically sealed embedded electronic systems, the principle of embedded functionality has the potential to radically alter our product expectations, whether we're design engineers or high street consumers. Now let's start looking at the bigger picture, not at the capabilities of 3D printing at the product design level, but at its potential to streamline our supply chains. And if I can call back to Kunal's comments right at the beginning of this webinar, the idea that 3D printing will upend the centuries-long paradigm of extended, interconnected global supply chains was the loudest message pushed by those magazine commentators and technology pundits back in the late noughties. 3D printing was going to democratize, localize, and reshore production. Well, we may not have lived up to that ideal, but we can see in practice that 3D printing, as a digital manufacturing platform capable of producing low-volume batches of individualized products, is indeed enabling businesses to reevaluate how they build and manage their supply and distribution chains, where they position themselves within that configuration, and how much the processes in that chain can be moved in-house, all with the ultimate goal to be more responsive, less wasteful, and reduce operational costs. In short, OEMs, suppliers, even customers are gaining increasing freedom to move more freely up and down their supply chains with a speed and ease we have not seen before, and in doing so, controlling supply, demand, cost, and price. An OEM, for instance, may decide that as part of a cost reduction exercise, they are going to consolidate their supplier base. And during this review, they may determine that a portion of low volume or critical parts currently sourced from suppliers can be manufactured in-house using 3D printing. Doing this would reduce total landed cost of those parts by eliminating supplier margins and reorder costs. Or perhaps instead, the value comes from reducing risk of stock outages for some specific critical parts that could cause knock-on costs in downtime. Conversely, a manufacturer could implement a lean initiative and transition to a pull system to reduce manufacturing waste. In this scenario, the customer is positioned right at the beginning of the supply chain, where they personalize the products they want to buy, then having their individual bespoke product additively manufactured only when the customer clicks order. A supply chain configuration where everything that is put into the manufacturing process has already been purchased. And one of the biggest opportunities for 3D printing to streamline supply chains that we see being adopted by industry today is ensuring the availability of legacy parts. As customers, we know the frustration when we discover that a spare part for an appliance, let's say a refrigerator, is no longer in production. And as business owners, we know the fear that can come with placing that final buy order for a series of replacement parts. 3D printing provides a solution to this problem. By allowing you to print individual parts on demand, companies can more effectively support their customers post-sale by ensuring that there will always be access to spare and replacement parts. The example given by Kunal earlier in this webinar with Porsche, for example, ensuring the availability of legacy parts for the classic car customer, demonstrates how this applies in a B2C, a business-to-customer context. But it can also work to empower parts suppliers and even logistic firms in a more business-to-business B2B context. Case in point, Renaissance Services, a systems integrator for the aerospace and defense sector in North America, and who have won a contract to maintain legacy aircraft for the US Air Force. Just like Porsche, they have turned to 3D printing and its ability to create one-offs on demand to maintain these legacy aircraft and equipment, specifically to produce gearboxes and housings. But unlike Porsche, Renaissance Services have taken a somewhat different approach. Firstly, they are not 3D printing gearboxes or engine housings directly. Because of their material and size, to do so would be cost prohibitive. Their approach was, if you can't print it, print the tool to make it. So they instead are using ceramic 3D printing to produce investment cast molds for these low volume components. This is an important point regarding how to find the value of 3D printing in supporting legacy equipment and maintaining part availability. Because of material requirements or maybe part size, 3D printing is not always a viable option outright. But if we assess the total landed cost of a part and the costs throughout a multi-stage production process that makes it, we can potentially use 3D printing to displace one or more of those high-cost processes in that chain, in that production chain. For example, having to produce one-off, high-cost ceramic molds for castings. Instead, we can 3D print these at a much lower cost. And ultimately, even though we're not printing the part outright, we are still using 3D printing to cut costs in production. And with the ability to reconfigure our supply and production chains to be more agile, responsive, flexible, and customer-driven, we can provide a level of hyper-personalization in the products that we make. Consumers are becoming more demanding. They want products and services that are both more on demand and personal to their unique tastes or specific requirements. Our one-size-fits-all economy meant that if you wanted personalization, it's going to come at a premium. 3D printing as a low-volume, on-demand production platform gives us the ability to revisit that equation. Kunal already demonstrated two examples from the medical device and gaming industries where this decoupling of personalization and premium meant the opening up of new revenue opportunities. And such is the case with many other industries, from robot bike, 3D printed bicycle components out of titanium to create frames that perfectly match the ergonomic measurements of the rider, to Multiply Labs, a pharmaceutical manufacturer creating patient-specific multivitamin tablets based on the customer's lifestyle choices. From sports to pharmaceuticals, 3D printing is allowing companies to reevaluate the equation between customization and cost, personalization and premium. In the auto industry, BMW Mini are taking hyper-personalization and putting it into practice by allowing customers to personalize trim and dash components of their line of Minis. In partnership with Twicket, a software development company, Mini developed a digital configurator which could allow customers to modify components of their Mini vehicles with images, textures and text. These trim components would then be 3D printed to the exact specs of the customer's design and then shipped to the customer who could install these bespoke trim pieces in their Mini. This is a drastic shift away from what was a very successful industrial model for car customization, modularity. We have all used online car configurators to design our dream car, whether or not we can ever hope to afford it. And we select from a range of styling options, as well as performance, security, infotainment, and other categories, to create our personal combination, a style that reflects us. This catalogue approach to customization means that the OEM can still benefit from economies of scale as they'll be buying large volumes of a relatively small range of paints, alloys, and trim, and the customer has a degree of design freedom in the buying process. Now, to put things into perspective of how successful this approach is, the Fiat 500 range has a total of 755,000 different configurations on styling alone. That's paint colours, wheels, fabric, dash styles and so on. And when we consider that there are 2.11 million Fiat 500s having been sold since the 2011 launch of the car, that means if we just look at the statistical numbers, your likelihood of driving past another Fiat 500 with the exact same configuration, at least in styling wise, as yours is 0.00007%. Put another way, you are twice as likely to be struck by lightning than come across another identical Fiat 500. And this approach doesn't just work for the auto industry. As an avid coffee drinker, I love citing the example of Starbucks. From their North American menu of less than 24 items, a customer can configure 200 million different espressos. So even with my best efforts, I will never get to try everything. So back to Mini. If we've demonstrated that a small number of options can provide a huge range of potential customizations for the customer, why move to full personalization? What's the benefit? The simple fact is that by using 3D printing, Mini can involve the customer much more meaningfully in the design and personalization process. And this is the key: consumer engagement and value-added experience. No matter how flashy a car configurator may be, no matter how many hundreds of millions of configurations you might be able to achieve, empowering the customer with the ability to physically design components adds significant value to the product and elevates its value in the eyes of the customer. Mini are utilising 3D printing to do just this: make the buyer feel like the designer by giving them the actual power of design. And the only viable production technology that can produce these personalised, unique parts and components in a single process is 3D printing. As a toolless digital production process, 3D printing is highly suited to low-volume manufacturing runs, from thousands of units down to the production of one. I've mentioned this capability throughout this webinar when describing the other drivers, and it is perhaps the most fundamental capability that 3D printing provides us. Whether you want to produce low volumes of spare parts or unique personalised products to a customer, it is all dependent on low volume manufacturing. Siemens Mobility in Germany are capitalising on 3D printing's low volume manufacturing capability to cut the costs of sourcing tooling. The RRX Rail Centre in Germany services over 100 trains a month, and these trains can be in very different conditions and wildly different ages. So Siemens Mobility needs to ensure that they have the correct stock available to service customers' locomotives as fast as possible and get them back into service. The issue is that more often than not, maintenance staff require custom tooling or very specific parts that just might not be available in inventory at the time. This has the immediate problem of delaying the servicing, but the additional cost of having to quickly source replacements, which can be expensive. Cue 3D printing. Siemens recognised that they needed a low-volume manufacturing solution that could handle the production of these low-volume intermittent part requests without the need for extensive tool setup or significant post-machining or labour. 3D printing was the optimal solution to meet those requirements. And this scenario is replicated in many different industries, from Heineken using desktop 3D printers to produce low-volume parts for their filling lines, cutting delivery time of those parts by 90%, to the example given by Kunal with Sandboxer, enabling digital content owners to manufacture low-volume, limited runs of merchandise that would have been cost-prohibitive to have done with conventional methods of production. And finally, our last driver, lifecycle sustainability. What do we mean by this? Well, when we consider the capabilities of 3D printing, from how we design to how we set up our manufacturing and how much product we produce, we have the potential to extend the operating life of our products and reduce the life cycle impact they have on our environment. A good example of this is in the aerospace industry, where there is significant investment in developing better airframe designs by using 3D printing. As I mentioned, 3D printing affords us much greater levels of design freedom. So we can produce structural components, such as brackets, for an aircraft frame that are optimised in their design and contain less material than conventionally cast or machined brackets. This lightweighting of the design not only uses less raw material, but improves the life cycle impact of the part, as a reduction in weight in an aircraft equals less fuel burned, which is both good for the environment and good for the bottom line of the company. Another example is refurbishing products to extend their operating life. Siemens Energy sector have done some really interesting work in this area, 3D printing in their gas turbine maintenance procedures. Rather than replace the components within their turbines that wear down over time from heat, Siemens have developed a bespoke metal 3D printing platform that allows them to remove these worn components from the turbines and refurbish them by adding material back onto the parts, essentially reversing the damage. This is not only more effective use of resources, but it eliminates the need for the remanufacture of brand new components, and the ability to potentially repair the damage can see the parts already in use continue to operate, reducing downtime as new parts are sourced, as well as eliminating a reorder cost. Ultimately, however, a lifecycle sustainability initiative has to also demonstrate, beyond environmental and community benefits, savings to the business. And EuroK shows us how this can be achieved by increasing product efficiency. EuroK GmbH, a design and engineering consultancy for the energy sector, has developed a novel microburner design. Conventional microburners process either gas or liquid fuels. The reason being is that different designs enable the efficient burn of different fuel types. The drawback to this is that although you gain better efficiency in your burner design, in that it's optimized to process one particular fuel source, you are then tied to that fuel type. And we know that the global fuel market is highly volatile, so there is always a risk that your fuel type, whether it be solid, liquid or gas, may wildly fluctuate in price. By utilizing freedom of design that comes with 3D printing, EuroK were able to design a burner configuration that could burn both liquid and gas fuel types interchangeably and efficiently. This meant that if one fuel type happened to increase drastically in market price, users of this particular burner design could simply switch to the alternative. So that was the rundown of our 6 drivers. I know it was a lot, and we covered a lot of topics and applications, but I hate to tell you this, but we've barely scratched the surface of this framework. There is a lot more to explore here. The 6 drivers are our fundamental principles for how 3D printing can add business value. These are the foundations of our thinking, our approach to understanding and communicating what 3D printing is capable of from a business mindset. But these are just principles. You may have noticed that in each of the case studies I presented, there was a particular phrase like embedded components or aesthetic personalization. These weren't random descriptors. They are the second level of our framework. And what does this second level look like? It looks like this: the 50 tactics. 50 examples of how each of the drivers are being applied by industry in the real world today. And I did warn you, there's a lot more below the surface. So if the drivers are principles for how, at a fundamental level, theoretical level, 3D printing can drive business value, the tactics are what you can reference to more deeply and precisely understand how a particular driver can be put into real-world action. In a manner of speaking, this framework can act both as a map and a menu. As a map, it allows you to explore and understand the landscape of 3D printing, what it can achieve and how it can be implemented to drive growth and eliminate costs. It's an almanac, a reference tool, for your understanding of the business benefits of this technology. But it can also be used as a menu of options for how you will implement the technology yourself, enabling you to select which drivers and which combinations of these tactics from across the full 50 you believe are applicable to you and your business and could help drive cost and growth. So to bring us full circle in this webinar, I want to call back to Bill's quote that we needed a new mindset, a new way of thinking, if we are really ever to benefit from the capabilities of 3D printing. The 6 drivers framework is the mindset that we use to help us at Blueprint navigate and leverage 3D printing, and we believe this is the mindset that is needed. It is one that does not hyper-focus on technological features, but considers the business angle of the technology, and in doing so, allows people, whether that's shop floor operators, designers, managers, or business leaders, to much more easily grasp the impact of the technology, understand its value, and, to Kunal's point about human barriers being that last roadblock to a greater level of additive adoption, reduce the fear and uncertainty in the people who are the ones who will ultimately see the benefits that this new technology brings. So this webinar has introduced the 6 drivers framework, and I have touched on some of those 50 tactics whilst giving a high-level description, a breakdown of each of those 6 drivers. For the rest of this webinar series, I'll be exploring in much greater depth each of these drivers in their own dedicated webinar episode, where we will drill down into each of these principles, understand the stark and nuanced ways in which they can disrupt different industries and markets, look at the tactics that comprise that driver, and look at a wide range of compelling case studies. So I urge you all to follow us through this series. My ultimate goal is that by the end of this, you will all be power users in this framework, and be able to articulate expert additive innovators, capable of communicating and championing the business benefits of 3D printing within your businesses. But if you cannot wait to watch the whole series, then firstly, I'm flattered. But we have produced a handy reference book that you can freely download from our website, additiveblueprint.com. We call it the Little Blue Book of 3D Printing. In here, you'll be able to read up on the full driver's framework, as well as explore the full 50 tactics, each and every one with an associated industry case study. In essence, it is a pocket-sized version of our full webinar series in paper instead of PowerPoint. And that is it from myself and Kunal. This brings us to the end of our first webinar in this series. I sincerely hope you have learned a thing or two, not only about some interesting examples of what 3D printing is doing in the real world, but how a different perspective, a new mindset, can really help to propel the understanding and utilization of 3D printing in your business. As I said, this is the first episode in the series, Beyond Products, How 3D Printing Can Drive True Business Innovation. So be sure to follow us on Twitter at the handle @3dprintpeople. Follow Blueprint on LinkedIn, as well as myself and the rest of the Blueprint team. We are prolific posters of interesting content, I assure you. And visit our website, www.additiveblueprint.com, to read our latest thoughts, content, webinars, and more. And if you want to reach out to myself, Kunal, and the team to talk about 3D printing, maybe a topic that we touched on in this webinar, or you just want to talk about where you are on your own 3D printing initiative or journey, please, I urge you to get in touch with us using the email hello@blueprint.com. As consultants, we learn and grow by hearing from individuals and organizations out in the real world on what they're doing and what they are thinking. So we'll be really eager to have that conversation. With that, I will sign off. I've been Oliver Smith, Senior Innovation Consultant at Blueprint, with my colleague Kunal Mehta, Head of Blueprint, and I shall say goodbye, thank you, and I really look forward to seeing you all throughout the rest of this series.